We're now going to go through a second example with sine functions. Notice that this sine function is a little different than the other one that we did previously. This sine function has a negative value as a coefficient, and it also has a fraction inside of the sine. But we still need to start the same way we would any other sine or cosine function, where we want to identify our three pieces of information: our amplitude, our period, and our midline, because with these we can go ahead and graph our function. Amplitude, we always want to look at the coefficient of our sine or our cosine function, and in this case our coefficient is -6, so we would say our amplitude is the positive value of that, which is 6. So from the midline we would go 6 values up and 6 units down to find our maximum and our minimum. Our period we find by taking the original period of sine, which is 2 pi, and dividing by whatever the coefficient of x is. Now with this being an x over 5, I would say that the coefficient is 1 over 5. And if I were to divide by this fraction, I could instead say this is 2 pi times 5 over 1, which then my period would equal 10 pi. So this is a much longer period than the original sine function because the x was being modified by division by 5. And if I look at my midline, I don't have any numbers being added or subtracted to the sine function, so I would say my midline is just at 0. It's going to be right on the x-axis. It has not been shifted up, it has not been shifted down, which does make things a little easier as we come over here to graph. Alright, so I'm going to draw my x and y axis, and that also has drawn my midline because it's on the x-axis. From that midline, I would look at my amplitude, which is 6, and I'd want to go up 6 units from my midline. I'd also want to go down 6 units from my midline. So my maximum and my minimum would be at 6 and -6. Now with any sine or cosine graph, we split it into 4 sections to represent those 4 quadrants. On that final one, we would want to label our full period, which in this case would be 10 pi. So I'm going to take that 10 pi and label it right there. In order to figure out what the other ones are, 10 pi is easy to cut in half, so I'm going to cut it in half and put 5 pi in the middle here. And 5 pi doesn't cut evenly, it gives us a decimal, so I'm going to write this first one as 5 pi, but divided by 2, because that's half the distance to 5 pi. I take 5 pi and cut it in half, that gives me my first one. Now the nice thing about finding that first one of 5 pi halves, I can then find any of the other segments just by multiplying by the value of the segment. So since we're looking for the third segment now, I would want to take the first segment and multiply it by 3. And 5 pi halves multiplied by 3 would give me 15 pi halves. So that gives me my 4 segments there labeled so that I can go ahead and start graphing. I'm going to change over to a different color here. Now a sine function starts on its midline. And with the midline being 0, I'm going to start at 0. With it being a negative out in front of the sine, instead of going up to start with, I'm going to go down. So I will start at 0, 0, and by the time I hit 5 halves pi, I should be down at my minimum value. By the time I hit 5 pi, I should be back to the x-axis. I should hit the maximum by the time I hit 15 pi halves, and then complete one period of the function by 10 pi by hitting the x-axis once again.